ahead and solder that resistor.
Ready, check. These guys are all soldering.
I can't screw this, but I'll get it there.
There you go. Thank you. Made it move.
You get the servo working, and you have played around with the servo program and saw where the center was, and then figured out where you're going to put the stick. Then you want to go through this activity.
I needed to know these two distances. So this one I actually measured the distance between the ruler and the turning point of the device. This one I came up with a little formula.
That's 25.
Here I wanted to set it up. I picked number 3 and I typed my equation in. So
yeah, I'm waiting for testing.
So you have a little screw, the retainer washer, and that groove.
Flat washer here and then the two.
Hey, thank you much.
Good. Testing this board. I'm short. That's good. Turn this light on. I think it's supposed to do that.
Flat line, it's the...
No. You know, I had a little trouble pushing one of these in. I wonder if one of the pins are there.
They look like they're in good. All right, let's try that again. It's about the 13th time I've done that. All right, now they should spin. And they are.
A lot of us get into a situation where we've got family. Just giving that as an example. An activity, just have it follow kind of a path. You make it up. Okay, something where you've got to go forward or turn or maybe reverse, whatever you will pattern. Okay.
Just strip on.
Okay.
I just want to make sure it was working. I'm happy.
I felt this. It's moving.
Program to make him go forward, buzzer on, and then back up.
We're always excited at TIs to see how people are using the system and using it in different ways that we don't know about or we haven't heard about. So it also helps as we start thinking about things we're going to do for the next versions and the next versions and the next versions to keep in mind needs of people and what they're already doing, and also to help make sure we don't accidentally orphan something that's a good
that's being used.
As it's being used, right? So part of it is just to come along and see levels of where the excitement is and where people are doing things. Honestly, some of the coolest things we see are things we never thought of.
Now I'm going to do the sound. I'm going to have a sound. I just did a loop. Well, you can take a look at what I have here.
You're not going to tell the robot where the ball is as a distance from the robot. You're going to tell the robot where the ball is as a distance from the light.
Cool. 2.0740.
So it looked at the intensity and said, wait a minute, this is for that distance based on your function, that intensity is too high. So it's going to go back until it gets the right intensity.
Yeah.
And then I have it
Nudge a little bit.
tweak a little bit.
It's nice.
This is an example of a program where it does a lot.
Right.
But the students don't have to do all that.
Right. All they did is run the
All they need to do is to help the robots take measurements for the situation it's in and help it use the right function to make this overall bigger
I
program.
want students to be able to enter the coordinates, the initial coordinates, and the final coordinates.
Where, so for example, I want to measure the height of a flagpole. So my thinking is this: I'll put this at the base of the flagpole. Tell what angle that I want the probe to be looking at.
Run the program again and have it go to a new position on the coordinate plane.
It's going to go up to the y-intercept of the line that would go through those 2 points, rotate to match the slope, go to the first point.
Go the line that's parallel or perpendicular.
Boy, it's going to come at you 80.